This is Advanced Math, Unit 5, Lesson 4. We're going to title this Complementary Cofunctions and even/odd functions. We will deal more with the even-odd functions in second semester as well, but right now we're going to talk about even-odd functions with sine, cosine, and tangent. Okay. Complementary cofunctions. It's kind of in the title what they are. Complementary, what numbers are complementary? Numbers that add up to 90, 60, and 30 are complementary. Cofunctions, the word co is the key word there. Co-functions. Okay, let's write this down. Sine of x will always equal cosine of 90 minus x. Remembering 90 is the same as pi over 2. Okay, and it's vice versa. You learned this back in math too, by the way. You may not remember it. Cosine of x will always equal sine of 90 minus x. Okay, supplement. Here's a supplemental piece. Complementary piece. X and 90 minus x are complements, right? If this was 30 and I did 90 minus 30, I'd get 60. 60 and 30 are complements. Sine, cosine. You may not have realized that before, but cosine, that co in front is because it's sine's cofunction. Sine, cosine. Cosine of x equals sine of 90 minus x. Got it? And I'll talk more in class. If you're not quite sure how this or why this is working, I will explain more in class, drawing pictures and working with special right triangles. Okay, next piece, secant of x equals. Now put co in front of the word secant and you get cosecant. Cosecant of 90 degrees minus x. Sine, cosine, secant, cosecant. So these are not the same as the reciprocal functions. They're not. Sine, cosine, secant, cosecant. You're looking and listening for the co in front of the functions. Okay, and it works both ways. Cosecant of x will equal secant of 90 degrees minus x. Okay, and the last one is tan of x equals, now tangent's the only one that works out the same as its reciprocal. Tan, you put the word co in front of it and you get cotangent. So tan of x equals cotangent of 90 minus x. And again, it goes both ways. Cotangent of x equals tangent of 90 degrees minus x. Okay, those are complementary cofunctions. We will do a few examples in just a little bit on what they're going to look like on the test and the quiz and homework. But right now, I want to quickly go through even and odd functions. Okay, an even function is when you take a function, you plug in the negative, but it does not change your answer. Here's what it looks like. Cosine of x, and I'm going to rewrite that, cosine of negative x will always equal cosine of positive x. Cosine of negative 30 will equal the same as cosine of positive 30. And I'm hoping that makes sense when you look at your quadrants. Cosine of negative 60 will equal cosine of positive 60. Cosine of negative 45 will equal cosine of positive 45. And you can put this on pause, pull out your unit circle, and check it. Does cosine of negative 60 equal cosine of positive 60? And yes, they do come out to be the same. That's called an even function. An odd function is for the sine and the tangent. That's when you plug in a negative x and you end up with the opposite. Negative sine x, negative tangent x. So what this is saying is if I found sine of negative 30, it would be equivalent of negative sine 30. Tangent of negative 30 would equal negative tangent of positive 30. So cosine absorbs the negative, sine and tangent kick it to the front. And again, I will explain a little more in class, and I'll draw you pictures and show you why cosine absorbs and how sine and tangent kicks it to the front. For now, I'd like to show you some examples. Okay, verify. Number 1, tan of pi over 2 minus x times secant x equals
William Corder, please come to the
cosecant
front
x.
office. William Corder, please come to the front office.
Okay, tangent of pi over 2 minus x times secant x equals cosecant x. Now I can see right off I'm going to want to work with this side because cosecant's 1 over sine, there's nothing else I can do with that. So this is the side that I'm going to want to manipulate. Not only that, this right here should be screaming at you. Change me, look, look, look. This right here is what we just wrote down. It's actually this one right here. Instead of 90, I used pi over 2 minus x. Tan of 90 minus x equals cotangent of x. So what am I going to change this to? Cotangent of x. Now, when you're taking the test and you don't have these up here, just remember, what's tangent's cofunction? Cotangent. What's the complement to 90 minus x? X. And cotangent and secant, we can change them both to sine and cosine. Cosine x over sine x, and secant is 1 over cosine x. And that reduces nicely, leaving me with 1 over sine. And look what I'm trying to prove, and sure enough, 1 over sine is cosecant of x equals cosecant of x. Again, this is, you're not boxing in because that's your answer. You're boxing in because you are done. You're telling me you're done. This right here, the work, is your answer for these type of problems. All right. Number 2, parentheses, 1 plus sine of y times the quantity of 1 plus the sine of negative y equals cosine squared y. I'm hoping by now you can see, hey, this is the one I'm going to want to use, to change, to manipulate, because it's a bit bigger, has more stuff to work with. 1 plus sine, there's really nothing you can do. The sine is not squared, and it's 1 plus, not 1 minus. And again, it'd have to be a sine squared anyway in order to use the Pythagorean identity. So there's nothing you can do here. But here, I'm hoping again it's screaming at you saying, change me, change me. Sine of negative y does what? Is this the one that absorbs the negative or kicks it to the front? It is right here. It kicks it to the front. Sine of negative x is negative sine x. So that one's going to change. First one's going to stay.
Kiana Brennan, please please come to the front office. Tiana Brennan, please come to the front office.
So this one's going to change to 1 minus sine of y. Do you see that? Stayed, changed. And then I'm hoping you can see, hey, I can double distribute this. That was one of my tricks to try that we had in our notes the other day. One of the tricks to try was to distribute or FOIL right here. Distribute was one of the tricks to try. So when we do that, we get 1 times 1 is 1 minus sine y plus sine y, take away sine squared y. Now, recognizing that eventually I'm not going to show this middle step because you learned middle step. You learned last year that when you multiply, these are called conjugates. When you multiply conjugates, the middles always cross out. 1 plus sine y, 1 minus sine y. You can also think of it as difference of two squares. When you FOIL a difference of two squares type problem, the middle terms cancel out, leaving you with 1 minus sine squared y. Right? If I gave you 1 minus sine squared and you factored, that's what you would end up with because the middle terms cancel out. Okay, now I have it 1 minus sine squared. Now I can use my identity. It is cosine squared. Why? Because of our first one, 1 minus sine squared equals cosine squared. So cosine squared y equals cosine squared y. And we are happy. Okay, number 3, we are going to write it as 1 over cosecant x plus cotangent x equals cosecant x minus cotangent x. All right, this is another one that's on the test. Not only is it on the test, it's one that's missed quite often. Of all the verify/proof type problems on the test, this is the one that's probably most missed. This one and the cube factoring. Okay, now what's different about this one is we haven't done this type of problem yet. If you remember from the notes last week, one of the tricks to try was the last one, multiply by the conjugate. And I told you guys then, we're not going to do this today, but we'll do it eventually. Well, today is the time where we're actually going to use it. Okay, pick a side. I picked the left side because it's the side that has the fraction. And I can multiply top and bottom by the conjugate. How do you recognize this? This is the important part that kids mess up on. Okay, so let me put a note here. This is a conjugate type problem. Okay, so when you see these two that are very similar, but this is a plus and this is a minus, that's kind of a big clue right there that you're going to multiply top and bottom by the conjugate. So I'm just going to rewrite it so that I can show the multiplying piece. Okay, so I rewrote it, and I'm going to multiply top and bottom by the conjugate. And I talked about the conjugate up here. It's where everything stays the same, you just change the middle sign. It's plus here, so it'll become minus. And then cosecant x minus cotangent x. All right, why do I do it top and bottom? Because these two things are exactly the same. This reduces to 1. 1 is the multiplicative identity, so multiplying by 1 does not change the value. I'm not changing its value, I'm just changing the way it looks. Okay, 1 times cosecant x minus cotangent is simply going to stay the same. Do you see that? 1 times, if I were to distribute, it's just cosecant x minus cotangent x. Okay, now I said earlier I wasn't going to FOIL the conjugates anymore, and I'm hoping you guys can see that. I'm just going to do the first and the last. Cosecant x times cosecant x is cosecant squared x That and that are going to cross out. Cosecant negative cotangent, cosecant positive cotangent, they're going to cross out. Negative, positive, they're going to cross out. So I'm not going to show that. Minus last terms, cotangent and negative cotangent is negative cotangent squared. Again, if you want, you can hit pause and FOIL the whole thing out like I did up here, and you will recognize and notice that the middle terms indeed do cross out. Okay, I can see what I'm trying to get, and look here, look at your notes from last week, at your identities. Does cosecant minus cotangent equal anything? Cosecant minus cotangent indeed equals 1. If I move that guy over, 1 equals cosecant squared minus cotangent squared. Cosecant x minus cotangent x over 1, and cosecant x minus cotangent x over 1 is just cosecant x minus cotangent x equals cosecant x minus cotangent x. And that is it for this lesson.